Hey there, this is Mr. Burton, and we're going to go over how to use the equation of a circle when you're given the center and the radius or other information, but we'll tackle that later. The most important thing about this concept is that everything you need is on the back of your formula sheet, and you just have to know how to pull that information out from the problem and use it appropriately. So one of the more important things is that the center of your circle is opposite in the formula as it appears on the picture or in the problem. So h is the x-coordinate of your center and k is the y-coordinate. But in the formula, it's actually the opposite of h and the opposite of k. So if they appear positive in the problem, in the formula they're going to appear negative. Also important to note is that the radius is r and it is going to be squared. Actually, everything is squared. It kind of looks like a squared plus b squared equals c squared, the Pythagorean theorem, and it actually does come from that, but we're not going to get into that now. So an important thing to note is that it's going to be three sets of parentheses squared. So something squared plus something squared equals something squared. That's how you're going to set up the equation of a circle every time. So let's actually get into this. The center is 2, 1, and the radius is 3. Well, if the radius is 3, the diameter is 2 times that, so it is 6. Let's go ahead and take this information and put it in our equation of a circle. So we have x minus 2 and y minus 1, and the radius is 3. And so now we're going to simplify. Can't simplify x minus 2, can't simplify y minus 1, but 3 squared is 9. Notice here that it looks like the x-coordinate is negative 2, but it's really positive 2. And it looks as though the y-coordinate is negative 1, but it's actually positive 1. It's the opposite of how it appears. Okay. Once we've got that information, we can actually draw the circle. And in order to draw the circle, we use the center and the radius, not the equation. So we're going to go 2, 1. There's our center. And now we're going to spread out 3 in every direction because the radius is the spread from the center to the edge. So I'm going to count 3 to the right and put a dot. 1, 2, 3. I'm going to go back to the center and count 3 up. 1, 2, 3. Back to the center, 3 to the left. 1, 2, 3. Back to the center, count 3 down. And I have 4 points on the circle. And so I'm going to list these. It's a little hard for me to do. 2, 4. 2, negative 2. 5, 1, and negative 1, 1. There are a lot more points on this circle. We should really sketch it as best as we can because it might be one of the other points on the circle, but those are the 4 easiest ones to get: north, south, east, and west. Kind of a long first example. Let's take a look at another one. This time they give me the diameter is 4, so I have to work backwards to get the radius. Well, 4 divided by 2 is just 2. The center is negative 6, 3. The radius is now, we learned, 2. And so now we're just going to plug and chug. X minus negative 6, y minus 3, and then 2 squared. Okay. Now here's x minus a negative 6. That's really x plus 6. Y minus 3 can't be simplified. And then 2 squared is 4. Once again, note, it's positive in the formula, but it's negative in reality. The y-coordinate is negative in the formula, but it's actually positive in reality. We're going to plot these real quick, but I'm not going to list them for the sake of time. So negative 6, positive 3 is right here, and I'm going to spread out not 4, but 2, because the radius is 2. So let's spread out 2 to the right, back to the center, 2 up, back to the center, 2 to the left, back to the center, 2 down, and just give it a little sketch. But those are the 4 points that we should list here. Let's do another. The diameter is 6, so I work backwards to get that the radius is 3. I have to divide it by 2 if I'm going backwards. The radius is 3, the center is negative 2, negative 1. So I have x minus a negative 2, y minus a negative 1, and then the radius is 3. 3 squared is 9, y minus a negative really becomes y plus 1, and it becomes x plus 2. Note that they're the opposite of how they are in the problem. I'm going to skip sketching it just to save some time. Now we're going to work backwards. When we're given the equation, we have to pull out the necessary information. So if it appears that the x-coordinate is negative 3 in the equation, the center is really positive 3. If it appears that the y-coordinate is positive 1, it's really negative 1. and was a little bit harder. The radius is not 49. That'd be a gigantic circle. The radius squared is 49, which really means, okay, what number times itself is 49? If you know your perfect squares, that number is 7. So if the radius is 7, 7 times 2 to get the diameter is just 14. And I'm not going to fill out the rest of the information. I think you're pretty good on the coordinate plane. Let's do another one just for practice. So I look here and I say, well, x doesn't have anything being subtracted or added to it, so what do I put there? Well, if there's nothing there, we're going to put 0. But the opposite of positive 6 is negative 6, so the y-coordinate is negative 6. And then once again, this is the radius times itself. So what number times itself is 1? Well, the only thing that does that is 1. So the radius is 1, the diameter is 2, because it's always radius times 2. We already have the equation, so we're not going to fill that out.